Hi. Most of our discussions about thermodynamics are around the concept of an ideal gas. So I want to introduce the basic concepts of ideal gas systems. So first off, in order to make a gas ideal, there are a few conditions that we're assuming. One, we're going to assume that the pressure of the gas is pretty low and the temperature isn't too hot or isn't too cold. It's just right. So too hot, too cold, we want to make sure that we're dealing with a gas, not a plasma, not a liquid, not some sort of supercritical fluid. It's just behaving as normal gas molecules that travel in a straight line until they collide with something. Because our second assumption is that there are no forces other than those forces experienced during a collision acting on any gas molecules or the walls of any container containing that gas. And speaking of containers, a container has some volume V. A gas molecule has some volume V0. To make this an ideal gas condition, we're going to assume that the total volume of our container is much, much greater than the number of molecules times the volume of an individual molecule. We're also going to assume that there are many molecules in a given container, and that's usually pretty good. Because in working with gases, we came up with a number that was very large. Because the number of gases, even in relatively small volumes, is very large. And that very large number is one of the 7 SI units, Avogadro's number, which represents the mole. 1 mole of things is, as of May 20th of 2019, 6.022140076 times 10 to the 23 things. Anytime you have that many things, you have 1 mole. Now, our ideal gas system, we're going to assume that heat could be exchanged through the walls, doesn't have to be exchanged through the walls. There is some pressure inside from collisions of the gas acting on the wall on the top. That wall's the only one that's free to move. Those collisions creating that pressure create a force all across the surface. So if there's any change in height, there's a change in volume, and we can do some work that would be equal to our pressure inside times the change in volume. And that pressure is part of the ideal gas law that says the pressure times volume is equal to the number of gas molecules times Boltzmann's constant times the thermodynamic temperature in Kelvin. And Boltzmann's constant is 1.38 times 10 to the negative 23 joules per Kelvin. Now, in moles, the pressure times volume would be the number of moles times the universal gas constant R times thermodynamic temperature, where that universal gas constant is 8.31 joules per mole Kelvin, and the number of moles is the number of things divided by Avogadro's number. Thanks for watching.